Hello, we would like to present a new patent-pending lid designed to minimize spillage with hot beverages. The infamous hot coffee lawsuit spurred the development of many spill-resistant lids. Unfortunately, all of the designs currently on the market are far from desirable. Our new design significantly improves upon what's currently available. There are 4 major improvements over current designs. They are: 1. It drastically reduces the amount of spillage. 2. It eliminates the need for the customer to pry open the lid before drinking. This is an especially dangerous two-handed action when driving. 3. It stops the dangerous and often messy splashback reported by customers when suddenly straightening an almost full cup. 4. The closed form helps to keep the beverage hot longer. We will explain each of these points in more detail as we progress through this presentation. As a baseline, here's one of the better designs currently in use. After receiving a drink with this lid, the customer has to lift the tab, bend it over, and snap it into the latch before beginning to drink. This produces a rather large hole in the lid for the liquid to flow. While it is possible to unsnap the tab and partially reclose the opening to prevent spilling, very few customers actually do this. Here is a second lid design in common use. As you can see, there is a fixed opening in the lid. Although the hole is somewhat smaller than the one in the previous example, there is no way to close the opening with this design. The new spill-resistant lid has 2 features that work together to prevent spillage. First of all, the customer does not need to do anything to begin drinking. No large opening is created in the lid. Instead, when the customer's mouth is placed against the lid for drinking, the customer's upper lip naturally pushes on the tab. This action automatically creates an opening in the lid. As soon as the mouth leaves the cup, the tab automatically springs back and closes the opening in the lid without any further action by the customer. Secondly, a scoop-like indentation is incorporated into the top surface of the lid. This shape, which is carried over from a proven patented technology for spill-resistant bottles, minimizes spillage when the cup tilts suddenly. Let's look at the spill-resistant lid some more. To drink from this new lid, one simply brings the cup to the mouth for drinking. This action causes the upper lip to push down on the integrated tab, creating a temporary opening for the liquid to flow. Once the cup is removed from the mouth, the tab automatically springs back and reseals the opening. Now let's see this in action. When the customer brings the cup to her mouth, her upper lip naturally pushes the tab. This automatically opens a hole in the lid for drinking. When the cup is removed from the mouth, the tab automatically recloses the opening. Now we will compare the new lid to the existing baseline lid. Here we have 2 cups filled with the same amount of tea. Our first test is the random shake. On the left, we have a cup with the baseline lid. And on the right, we have a cup with a new spill-resistant lid. Moving the cups to the left and right, up and down, front and back, or in a circular motion, we can see liquid spilling out of the drink opening in the baseline lid. Looking inside the cups, we can see that there is a large difference in the amount of remaining liquid between the 2. Very little tea has escaped out of the spill-resistant lid. Next, we will repeat the same test with the second lid design in common use. In the random shake test, we can see the tea spilling out of the hole in the white lid. Looking inside the cups, we again can see a difference in the amount of remaining liquid. Next, we demonstrate a sudden tilt scenario. Again, we begin with 2 cups filled with equal amounts of liquid. To reduce the possibility of spilling with the baseline lid, we have unsnapped the tab and reclosed the opening. Now we show a sudden jerking action. Despite having reclosed the mouth opening, significantly more liquid still comes out of the baseline lid. Now let's take a look inside the cups. Clearly, much more liquid has escaped out of the baseline lid. Very little liquid has escaped out of the spill-resistant lid. Let's repeat that test with the second lid design in common use. Again, we begin with 2 cups filled with equal amounts of liquid. The fixed opening in the white lid permits significantly more liquid to escape compared to the spill-resistant lid. Looking inside, the difference in the amount of remaining liquid in the 2 cups is evident. In summary, we are introducing a new lid design whose shape resists spilling. The new design improves over existing lids in 4 major areas. Firstly, in repeated testing as shown, the spill-resistant lid drastically reduced spillage by more than 90% compared to the leading existing design. Secondly, the lid cover opens and closes automatically as part of the natural drinking motion. There is no need for the customer to pry open a tab. Thirdly, the new design stops the dangerous and often messy splashback associated with a sudden movement after taking a drink from a nearly full cup. Finally, the lack of a large hole keeps drinks hot longer. The new spill-resistant lid is made using the same thermal vacuum forming process as existing lids and does not cost any more to produce. Our demonstration has clearly shown that the new design outperforms existing lids in preventing spills. Thank you very much.